Lecture 133. Record-breaking inventions and innovations, dramatic orchestral music, fades in welcome to the fascinating threshold where human ingenuity collides with our obsession for breaking boundaries. I'm your guide through this labyrinth of record-shattering creativity, where the smallest, largest, fastest, and most extraordinary inventions have forever altered our perception of what's possible. Today, we venture into the mysterious realm of record-breaking inventions and innovations, creations that didn't merely improve upon their predecessors, but obliterated previous limitations in ways that left the world breathless. Throughout history, a peculiar force has driven inventors and innovators, not merely to create, but to transcend. This compulsion to surpass boundaries has propelled humanity from stone tools to spacecraft, from candlelight to quantum computing. The enigma of human progress is written in these moments of breakthrough, these instances where someone dared to ask not, how can we make this better? But rather, how can we reimagine what's possible? These questions have birthed inventions that didn't just set records, they redefined our understanding of reality itself. But what exactly constitutes a record-breaking invention? The metrics are as diverse as innovation itself. Some innovations captivate us with their minuscule dimensions, others with their colossal scale. Some bewitch us with unprecedented speed, while others mesmerize with unfathomable efficiency. The most baffling break multiple barriers simultaneously, creating entirely new categories of human achievement. What binds these disparate creations is their defiance of assumed limitations, their ability to transform impossible into inevitable. Let's begin our journey in the realm of the infinitesimal, where record-breaking occurs at scales invisible to the naked eye. In 2021, researchers at Northwestern University created the world's smallest human-made flying structure, a microflyer smaller than a grain of sand that can be carried by the wind like a maple seed. This winged microchip represents a profound breakthrough in environmental sensing, medical implantation, and surveillance technology. Even more perplexing is the world's smallest electronic circuit, measuring just 2 atoms in thickness. Created at the quantum level, these circuits operate in a domain where the conventional laws of physics begin to unravel, opening gateways to computing power once thought unattainable. Perhaps most captivating are the microscopic robots now navigating the mysterious terrain of the human body. Harvard's Microrobotics Laboratory shattered records with their millimeter-sized robotic insects capable of controlled flight. Meanwhile, Cornell University created microscopic robots smaller than the width of a human hair that can walk autonomously using electronic brains. Most enigmatic of all are the molecular machines, synthetic molecular structures designed to perform mechanical movements in response to specific stimuli. These nanoscale creations earned their inventors the 2016 Nobel Prize in Chemistry and opened doorways to targeted drug delivery systems that navigate the body's labyrinthine pathways with unprecedented precision. The implications stretch far beyond medicine, into computing, materials science, and environmental remediation. We stand at the threshold of a world where invisible machines reshape reality at its most fundamental level. At the opposite extreme lie inventions of staggering magnitude, colossal creations that defy our intuitive understanding of scale. The Bagger 293 excavator, standing 96 meters tall and 225 meters long, remains the largest terrestrial vehicle ever constructed. This behemoth can move 240,000 cubic meters of earth daily, enough to fill 96 Olympic swimming pools, yet requires only a handful of operators. Even more perplexing is the Large Hadron Collider, a 27-kilometer ring of superconducting magnets buried beneath the Franco-Swiss border. This massive apparatus accelerates particles to 99.999999% the speed of light, recreating conditions from the first moments after the Big Bang. In space, the International Space Station reigns as humanity's largest off-world construction, a 420-ton laboratory orbiting 400 kilometers above Earth at 28,000 kilometers per hour. The engineering challenges of such massive scale border on the mystical. How does one move components weighing hundreds of tons? How are tolerances maintained across structures spanning kilometers? How do materials withstand forces never before encountered? Consider the Three Gorges Dam, a wall of concrete stretching 2.3 kilometers across China's Yangtze River. This 185-meter-high barrier required engineers to redirect one of Earth's mightiest rivers and calculate pressure distributions across an unprecedented concrete volume. The most baffling aspect of these megastructures isn't their size. It's the fact that they begin as nothing more than equations and sketches, transformations of thought into matter on scales that defy comprehension. Humanity's fascination with speed has produced some of our most captivating record breakers. The land speed record has been shattered repeatedly, from the first automobile to break 100 km/h in 1899 to the current record holder, Thrust SSC, which achieved 1228 km/h in 1997, becoming the first land vehicle to break the sound barrier. In water, the Spirit of Australia holds the water speed record at 511 km/h, a mysterious boundary that few have attempted to cross due to the lethal physics of hydroplaning at such velocities. In the air, the North American X-15 reached 7274 km/h, Mach 6.7, while still in Earth's atmosphere, a record set in 1967 that remains unbroken by any crewed atmospheric aircraft. But the true enigma of speed lies in understanding its barriers, the thresholds where physics itself seems to resist our advancement. The sound barrier once appeared impenetrable until Chuck Yeager's historic flight in 1947. Now we face the heat barrier, where air friction generates temperatures that would melt conventional materials. Perhaps most perplexing is the approach to light speed, where relativistic effects begin to manifest and time itself becomes malleable. While we're unlikely to break this ultimate speed limit, the pursuit itself has yielded profound innovations in materials, propulsion, and our understanding of physics. The NASA Parker Solar Probe, the fastest human-made object, reached 163 km per second, 586,800 km/h, during its close approach to the Sun, yet this represents a mere 0.05% of light speed. In our energy-constrained world, efficiency records hold particular enchantment. Solar cell efficiency has repeatedly shattered barriers, from Bell Labs' first practical photovoltaic cell at 6% efficiency in 1954 to modern multi-junction cells exceeding 47% efficiency, approaching the theoretical limits of photovoltaic conversion. At the National Ignition Facility, researchers achieved the first fusion reaction to produce net energy gain, a watershed moment in humanity's quest for limitless power. Meanwhile, the computing industry has repeatedly defied Moore's law's supposed limits, creating processors that perform trillions of calculations per second while consuming less power than a light bulb. Battery technology represents one of the most intensely contested fields for record-breaking innovation. The energy density of batteries has increased nearly threefold in the past 3 decades, a trajectory that has transformed everything from smartphones to transportation. Quantum glass batteries promise to shatter these records again, potentially storing 5 times more energy than lithium-ion cells while charging in minutes rather than hours. Most intriguing are biobatteries that harness metabolic processes, like those developed at MIT that generate electricity from glucose in the bloodstream, potentially powering medical implants indefinitely. Sustainability innovations have broken records that transcend mere technical specifications. They've begun to reverse humanity's ecological footprint. Carbon capture technologies now extract CO2 directly from the atmosphere at rates once thought impossible. The Orca plant in Iceland can remove 4,000 tons of carbon dioxide annually, a record soon to be dwarfed by mammoth, which will capture 36,000 tons. Plastic-eating enzymes developed by the University of Portsmouth can now degrade plastics in days rather than centuries, an acceleration of natural processes by factors of millions. Most captivating is the emergence of regenerative agriculture techniques that can sequester more carbon annually than traditional farming releases, transforming agriculture from a carbon source to a carbon sink. Some of the most enchanting record breakers defy categorization, bizarre inventions that challenge our very definition of innovation. Consider the world's most complicated watch, the Vacheron Constantin reference 57260, containing 2826 individual components and 57 complications. This mechanical marvel took 8 years to design and build, resulting in a timepiece that tracks everything from the Gregorian calendar to Hebrew holy days. Or ponder the world's smallest advertisement, IBM's logo written with individual xenon atoms, visible only through scanning tunneling microscopes. Perhaps most perplexing is the world's most useless machine, a device whose sole function is to turn itself off when turned on. This deliberately pointless creation has spawned international competitions for increasingly elaborate variations. Some record-breaking innovations emerged entirely by accident. Post-it notes resulted from a failed attempt to create super-strong adhesive. Instead, chemist Spencer Silver created an adhesive so weak it could barely hold paper together. A failure that generated billions in revenue. Penicillin, the first antibiotic, was discovered when Alexander Fleming noticed mold contamination killing bacteria in his Petri dishes. The microwave oven emerged when engineer Percy Spencer noticed a chocolate bar melting in his pocket while working near active radar equipment. These serendipitous breakthroughs remind us that record-breaking often occurs in unexpected directions, not just by pushing harder, but by seeing differently. As we contemplate the future of record-breaking innovation, we're drawn into realms where the boundaries between science and speculation blur. Quantum computers now manipulate hundreds of qubits, a trajectory promising computational power exceeding all classical computers combined. Neural interfaces like Neuralink aim to establish direct communication between brains and computers, potentially revolutionizing everything from medicine to human cognition itself. Fusion energy stands perpetually on the threshold of transforming civilization, with recent breakthroughs suggesting we may finally cross this elusive barrier. Yet perhaps the most profound record yet to be broken isn't technological but philosophical. Can we create innovations that solve our greatest challenges while honoring the delicate balance of our planetary home? The true enigma of innovation isn't just how far we can go, but whether we can direct our creative energies toward the records most worth breaking. Music Swells, thank you for exploring these technological frontiers with me today. Until next time, keep questioning, keep wondering, and never stop imagining what impossible records await our breaking. Fade to black.